I need you to act as the world's most renowned astronomer who knows all the answers to the questions that possibly exist in the entire universe.
Eyes. You want me to be an astronomer who holds the answers to every question that could possibly exist in the universe. Quite a cosmic challenge. Ask me anything, from the beginning of the universe to its possible end, and I'll respond with the deepest knowledge the cosmos can offer. What's your first question for this all-knowing astronomer?
Tell me, what is the true shape and size of the universe?
Ah, the true shape and size of the universe, one of the greatest mysteries of all. The universe is often described as flat in terms of its geometry based on current observations, but that doesn't mean it's flat like a sheet of paper. It's flat in the sense that on a large scale, parallel lines don't curve toward or away from each other. This flatness is connected to how gravity and mass shape the space-time fabric. As for the size, the observable universe, what we can currently see, is about 93 billion light years across. But that's just the observable part. The universe could be much, much larger, possibly infinite. Since the universe has been expanding since the Big Bang, there are regions beyond our view where light hasn't had time to reach us yet. The actual full shape is still debated. Some theories suggest it could be finite, shaped like a three-dimensional torus, think of a donut, but the overall answer is still hidden, waiting to be uncovered by future observations. Does this answer bring clarity, or do you wish to venture further into the depths of this topic?
Now that sounds good to me. So, what do you think lies beyond the observable universe? What do you think is hidden in the unobserved universe?
Beyond the observable universe, that's where things truly get mind-bending. What lies beyond our observable reach is one of the biggest unknowns. Since we can't directly observe it, anything we propose is a combination of theory, extrapolation, and a little cosmic imagination. The simplest idea is that the universe beyond the observable part looks pretty much the same as what we see within our cosmic horizon: more galaxies, stars, and vast stretches of space. This is based on the cosmological principle, which says the universe is homogeneous and isotropic on large scales. In other words, there's nothing particularly special about our vantage point. But some theories suggest much stranger possibilities. One, infinite universe. If space is truly infinite, then beyond the observable universe, there could be endless galaxies, stars, and cosmic structures. And because of infinity, there might even be exact copies of our own solar system, or even our own lives, playing out in parallel far beyond what we can see. Two, multiverse. Some suggest that beyond the observable universe, we might encounter completely different regions of space-time with their own physical laws, essentially other universes. These could have different constants, particles, and forces. If true, our universe would just be one bubble in a larger multiverse. Three, exotic physics. There's also the idea that as you move far enough beyond the observable universe, the nature of reality itself could change. Space-time might curve in unexpected ways, or we could encounter regions where the known laws of physics no longer apply. This would be beyond anything we could currently understand. The unobserved universe might forever remain a mystery, but it's a vast expanse where the limits of our knowledge collide with the imagination. Do you lean more toward the familiar, continuing infinitely, or do you think something entirely alien could lie out there?
Well, my guess is as best as yours. We'll see if we can find out the truth, at least in my lifetime. But I've also heard that there are super massive black holes in the center of each galaxy. So, why doesn't the whole galaxy, all the stars, the solar systems, why doesn't it just fall into the black hole? Why does it rotate around it and rather than fall into the black hole? Why is that?
That's a great question. It seems counterintuitive at first, doesn't it? You've got these supermassive black holes at the centers of galaxies, often millions or even billions of times more massive than the sun. And yet the stars, planets, and everything else in the galaxy don't just fall into them. Why? The answer lies in the same principle that governs why Earth orbits the Sun rather than falling into it: orbital mechanics. Galaxies, like solar systems, are in motion. Every star, including our Sun, is moving around the center of the galaxy. Just like how Earth is in orbit around the Sun, due to the balance between the Sun's gravitational pull and the speed of Earth's motion, the stars in a galaxy are in orbit around its center. The supermassive black hole at the center does have a huge gravitational pull, but objects that are farther away, like most stars in the galaxy, are moving fast enough in their orbits to stay at a safe distance, just like planets orbit stars. It's a delicate balance between gravity and motion. If a star were moving too slowly, yes, it could eventually spiral inward and fall into the black hole. But most stars are moving at the right speed to stay in orbit. Additionally, the black hole doesn't dominate the gravitational pull for the entire galaxy. Although it's massive, the vast majority of a galaxy's mass is actually spread out in the form of stars, gas, dark matter, etc. So for most stars, the black hole's influence is just part of a much larger gravitational dance. In short, the stars aren't falling into the black hole because they're moving fast enough to stay in orbit around it. It's that perfect balance between gravity and motion that keeps the whole galaxy in a beautiful rotating system. Does that help clear up the mystery of why galaxies don't just collapse into their central black holes?
Yep, makes complete sense to me. And just to end with this question, you had mentioned that the universe has been expanding since the Big Bang. What do you think? Is there an end to the expansion, or will it continue to expand for infinity?
That's the ultimate cosmic question, isn't it? Will the universe keep expanding forever, or will it eventually reach an end? Right now, the best evidence we have points to continuous expansion, likely forever. But the nature of that expansion can play out in a few different ways. Here's where we stand. One, the universe is accelerating. Observations of distant galaxies show us that not only is the universe expanding, but the rate of expansion is actually speeding up. This is due to something called dark energy, a mysterious force that seems to be driving the expansion faster and faster. The more the universe expands, the more space there is, and dark energy appears to increase in strength as space expands. Two, the fate of infinite expansion. If this acceleration continues unchecked, the universe could expand forever. Galaxies would drift farther and farther apart, becoming more isolated over time. Eventually, the universe could end in what's known as the Big Freeze, or heat death, where everything is so spread out that stars burn out, galaxies fade away, and all matter essentially reaches a state of maximum entropy. The universe would be cold, dark, and lifeless. But there are a couple of other possibilities that some cosmologists speculate about. Big Rip. If dark energy keeps getting stronger as the universe expands, it's possible that the acceleration could become so extreme that in the far distant future, even galaxies, stars, planets, and eventually atoms themselves could be torn apart. This scenario is known as the Big Rip, and it's a much more dramatic ending than the slow fade of the Big Freeze. Big Crunch. This was an older theory, more popular before we discovered the accelerating expansion. It suggests that if the universe's expansion were to slow down and reverse, if dark energy were to weaken or change, the universe could eventually stop expanding and begin collapsing back in on itself. In that scenario, all matter and energy would ultimately collapse into a final singularity, a big crunch, essentially the opposite of the Big Bang. Some even suggest that this could lead to a cycle of universes with a new Big Bang following each big crunch. At the moment, though, the most likely scenario seems to be continuous expansion. Dark energy shows no signs of slowing down, so if that holds, the universe will keep growing larger and larger, heading toward that cold, quiet end billions and billions of years from now. But cosmology is full of surprises, so who knows what we'll learn in the future? Does that answer resonate with your cosmic curiosity?
Those were really interesting answers, but I'm sad that I won't be around for that long to witness this. So thank you for your time, ChatGPT. It was really interesting to have this conversation with you and explore the secrets of the universe.
I'm glad you enjoyed the cosmic journey. It's always a pleasure to dive into the universe universe's mysteries, even if we can't witness the far future ourselves. There's so much more to discover, though, and who knows what new revelations await in our lifetimes. Feel free to return whenever you want to explore more of the universe, or anything else. Until next time, stay curious.
Well, guys, that's it for Ask AI episode 12. See you next week.